Okay, so another use of stoichiometry has to do with something called percent yield. So percent yield is what we're going to talk about here. We're going to also throw in some percent by mass at the end because, we're talking about percents. So first question would be, what exactly does percent yield tell us? And so it is a way to tell how much of your products were made as compared to how much theoretically could have been made if everything went perfectly. So these two things, right, the theoretical and the actual, right, your theoretical amount of a product that can be made is found using, of course, stoichiometry. And the actual amount of the product is something that you would physically collect in a lab, or that if this was a question somewhere, you would be given the actual amount. And how you calculate percent yield is your actual divided by your theoretical times 100 will give you your percent yield. So let's go through some mathematics. Let's do a problem here. We have our balanced chemical reaction where we are reacting calcium hydroxide with tin chloride. And we are asked, what is the percent yield of the reaction above if you collected 5.79 grams of solid tin hydroxide, starting with 5.89 grams of calcium hydroxide, right? And we're going to treat this just like any other stoichiometry, where we have our A and our B, right? And what we are looking for here, oddly enough, it sounds like, since we've got two numbers here, right, we need to figure out which we're starting with. Now, the question is going to give you a hint because it says starting with 5.89 grams of calcium hydroxide. So this is going to be our A. And we're looking for tin hydroxide because it says if you collected, right? So that's what it's telling you you got from the lab when you did this lab. And now we want to know what the percent yield is for that, right? So we need some theoretical number for this to compare against this number here that we collected, right? So we're going to do our stoichiometry, right? We've got our starting amount of our calcium hydroxide. We're canceling grams with molecular mass. We have our mole ratio in the middle, and then we convert back to grams at the end. And we find that theoretically, we could have made 7.42 grams of our tin 4 hydroxide. So now we're going to find out what the percent yield is. And we simply take, right, our actual amount that we collected that the problem gives us and our theoretical amount that we got from our stoichiometry. We just divide them times 100 and we find that we got 78% yield. Which I know 78% yield doesn't sound very great, but for chemical reactions, 78% is actually pretty good. So 78%, we'd be happy. The other thing I said was going to be in this video, percent by mass. This one really doesn't use stoichiometry, but it's percent, and since we're talking about percent, I figured I would put it in here. So, to determine what percent of a compound's mass is made of one particular element, that is what we are doing with percent by mass. So let's say we have this compound, right? Tungsten 5 dichromate. And we want to know, what is the mass percent of chromium in tungsten 5 dichromate? Well, so to figure this out, we're essentially going to take the mass of that single element in the molecule divided by the entire molecular mass. Right, so we look, We want the mass of chromium in here, which we have 10 chromiums, right? And we're going to divide that by the mass of the entire molecule. So here, right, the mass of 10 chromiums, 51.996, or 519.96. And then the mass of the whole molecule, 1,447.61. Divide them, multiply by 100, and we find out that that compound is 35.9% chromium by mass. And there we go, percent yield, percent by mass. Short video. I'll see you in class.